Hello everyone and welcome to our new video. You might have seen this kind of expression mostly in signal processing and signals and system courses, that we got a summation that exists from 0 to length n and its sum is equal to this thing. So you might wonder how this terms comes from the expressions. So in this tutorial we will try to learn where this term come from. So let's assume if I say this whole thing equal to s means equal to summation n from 0 to n alpha power n. Now if I open this summation, this becomes 1 plus a square and up to plus alpha power n minus 1 plus alpha power n, right? Now what I am going to do is I multiply this whole expression with a constant term a. So this shall become a summation n from 0 to alpha power n, right? Now you can see this a is multiplied with each of these terms, then this whole expression shall become a plus a square plus a cube plus up to plus alpha power n plus alpha power n plus 1, right? Now what if I subtract this as from this s? Then what we get is, now you can see, now this one shall remain positive, this a is positive, and this shall be subtracted from the above expression. So this shall become minus, and then we got a here plus a square minus a square plus up to plus a power n minus l power n. And now you can see this this term is subtracted from this term, and what we are left with is this term, right? So instead of plus, this shall become minus alpha power n plus 1. Now you can see these terms get cancelled, and what we are left with is, if I take s from common from here, then this become 1 minus a, that is equal to 1. This whole expression shall get cancelled, and all we are left with is minus alpha power n plus 1, right? Now you can see, if I want to calculate the value of this s only, then this term that is multiplied with s should be divided on the right hand side. So what we are left with is 1 minus alpha power n plus 1 upon 1 minus a when alpha is less than 1. Okay, so we have proved this property, that this is equal to this thing. Now another thing that you might have noticed in signal processing, sometime this summation goes to infinity, n from 0 to infinity alpha power n, that is equal to 1 upon 1 minus a. So where does this thing comes from? Now let us see. We know that n from 0 to capital N alpha power n is 1 minus alpha n plus 1 upon 1 minus a, right? Now you can see, we know that this alpha is less than 1. As we keep on increasing the value of this n, this term should be reduced, right? So what if this n becomes infinity? If this n becomes infinity, then we get alpha power infinity, and we know this alpha is less than 1. So each time if you increase the value of n, this terms get smaller and smaller, and when n approaches to infinity, this shall become 0. So if this term becomes 0, this terms becomes 0, then what we are left is 1 upon 1 minus a when a is less than 1. You might have noticed in many transforms, for example, in Z transform, we normally get this term, and we say this is equal to 1 upon A Z inverse, given A Z inverse is less than 1. So rearranging this summation, we get Z greater than A. So you may find this geometric sequence very useful in signal processing. I hope you like it, and